Hello everyone. In this video we are going to discuss about scalar point function and its properties. Before taking definition of gradient, we have to know some definitions. So first definition is scalar point function. For each point p of xyz, there exists a scalar pi of xyz. Then pi of xyz is called a scalar point function and the region R is called scalar field. For example, water pressure. So pressure has only magnitude and no direction. So that's why pressure is a scalar point function. Another example, P equal to x square plus y square is a scalar point function of two-dimensional scalar field. And P of xyz equal to x square plus y square plus z square is a three-dimensional scalar field for each point P of x, y, z. And physical examples are the mass density and the temperature are the scalar point functions because which has only magnitude and no direction. Next, vector point function. So vector point function. For each point P of x, y, z, there exists a unique vector denoted by f bar. Then f bar of x, y, z is called a vector point function and the field R is called vector field. For example, the velocity of wind. The velocity of wind has magnitude and direction. So velocity of wind is a vector field. Another example, f bar equal to xi plus yj plus zk is a vector point function. And the velocity of wind, already we discussed, the velocity of wind is a vector point function. We are going to define vector differential operator, which is the most important for this vector differentiation and integration. So the vector differential operator is denoted by del and read as del, and is defined as del equal to I dou by dou x plus j dou by dou y plus k dou by dou z. Gradient of a scalar point function. The gradient of scalar point function is denoted by del pi or grade pi and is defined as del pi equal to grade pi equal to I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z, which equal to summation I dou pi by dou x. And note, the gradient of a scalar point function is always a vector point function. Properties of gradient. First property, del pi denotes the vector normal to the level surface pi of xyz equal to c, and del pi by mod del pi is denoted by unit vector normal to the surface pi of xyz equal to c. Next, second property is, if theta be the angle between two surfaces pi 1 and pi 2, then cos theta equal to del pi 1 dot del pi 2 by mod del pi 1 into mod del pi 2. Two surfaces cut orthogonally, then the angle is pi by 2. That is theta equal to pi by 2. If theta equal to pi by 2, then cos pi by 2 is 0. This implies del pi 1 dot del pi 2 by mod del pi 1 into mod del pi 2 equal to 0. From this we will get del pi 1 dot del pi 2 equal to 0. Mod del pi is the greatest rate of change of the surface pi of xyz equal to c, which is also called greatest rate of increase. The greatest rate of increase of scalar point function pi of xyz equal to c is mod del pi. Now we are going to discuss some examples. First example, find grade pi for pi equal to x y square z cube at the point 1 1 1 on this topic. Grade pi equal to I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. So this equal to I into differentiate pi with respect to x partially, we get x derivative 1 into y square z cube plus j into dou pi by dou y. Differentiate pi with respect to y partially. We get y square derivative is 2y into x z cube. So 2x y z cube plus k into differentiate pi with respect to z partially. We get z cube derivative is 3z square into xy square. So 3x y square z square. Now we have to find gradient at the point 1 1 1. grade pi at 1, 1, 1. Substitute x equal to 1, y equal to 1, z equal to 1. We get I plus 2j plus 3k, which is the gradient of pi at the point 1, 1, 1. Next example, find the unit normal to the surface x square y plus 2xz equal to 4 at the point 2, minus 2, 3. So to find unit normal, first we have to find the normal to the surface. Let given surface we have to denote by pi. Pi of x comma y comma z equal to x square y plus 2xz minus 4. Next, to find unit normal to the surface, first we have to find the normal to the surface pi. So the normal to the surface pi is equal to del pi, and del pi equal to I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. So this equal to I into dou pi by dou x. Differentiate pi with respect to x partially. 2xy plus 2z plus j into differentiate pi with respect to y partially. So y derivative 1 into x square plus k into dou pi by dou z. Differentiate pi partially with respect to z, we get 2x. Now del pi at the point 2, minus 2, 3. This equal to, substitute in place of x 2, in place of y minus 2, in place of z 3. Then substitute here x equal to 2 and y equal to minus 2. So 2 2s are 4 into minus 2, minus 8. Next z equal to 3 plus 6 plus j into x square. X square means 2 square is 4 plus k into 2x. X equal to 2. 2 2s are 4. This equal to minus 8 plus 6. So minus 2i plus 4j plus 4. Okay. This is del pi. Right. Now, to find unit normal vector, unit normal vector to pi equal to del pi by mod del pi. So this equal to del pi minus 2i plus 4j plus 4k by mod del pi equal to I coefficient whole square plus j coefficient whole square plus k coefficient whole square. This equal to this equal to, we can take 2 common from the numerator, minus I plus 2j plus 2k by 4 plus 16 plus 16, 36. Root 36 is 6. So, this equal to 1 by 3 into minus I plus 2j plus 2k, which is the unit vector normal to the surface. Next example, find the angle between the tangent planes to the surfaces x log z equal to y square minus 1 and x square y equal to 2 minus z at the point 1, 1, 1. Solution. So let us assume that the first surface has a pi 1 and the second surface has pi 2. Let pi 1 equal to x log z minus y square plus 1, pi 2 equal to x square y plus z minus 2. So we have to find first del pi 1 and del pi 2. Del pi 1 equal to I dou pi 1 by dou x plus j dou pi 1 by dou y plus k dou pi 1 by dou z. This equal to I into dou pi 1 by dou x. Differentiate pi 1 with respect to x partially. We get x derivative 1 into log z plus j into dou pi 1 by dou y. So y square minus y square derivative is minus 2y plus k into dou pi by dou z. Dou pi by dou z, x into log z derivative is 1 by z. So x by z. This is del pi 1. Next, del pi 2. Equal to I dou pi 2 by dou x plus j dou pi 2 by dou y plus k dou pi 2 by dou z. This equal to I into dou pi 2 by dou x, 2x y plus j into dou pi 2 by dou y, x square plus k into dou pi 2 by dou z is 1. Now we have to find del pi 1 at the point 1, 1, 1. This equal to, substitute x equal to 1, y equal to 1 and z equal to 1. So x equal to, first z equal to 1. Log 1 is 0, 0 I. Next y equal to 1. So minus 2j. Next x is 1 and z is 1 plus k. Next del pi 2 at 1, 1, 1. So 2i plus j plus k. Right. If theta be the angle between pi 1 and pi 2, then cos theta equal to del pi 1 dot del pi 2 pi mod del pi 1 into mod del pi 2. So this equal to, first substitute del pi 1. Del pi 1 at the point 1, 1, 1 is 0i minus 2j plus k dot, next del pi 2, 2i plus j plus k by mod del pi 1 root 0 square plus minus 2 whole square plus 1 square into 2 square plus 1 square plus 1 square. This equal to dot product. Dot product of two vectors is the coefficients of product of coefficients of I, j, k, and so 0 into 2 is 0 plus minus 2 into 1 plus k coefficient 1 into 1 by, this is root 5 and this is 2 square is 4 plus 1 plus 1 root 6. This equal to minus 2 plus 1. So minus 1 by root 30. Cos theta equal to. This implies theta equal to cos inverse of minus 1 by root 30, which is the angle between the two surfaces, given surfaces. Next example, find the angle between the normals to the surface xy equal to z square at the points 4, 1, 2 and 3, 3, minus 3. So let pi equal to xy minus z square and find the normal to this surface. Del pi equal to I dou pi by dou x plus j dou pi by dou y plus k dou pi by dou z. This equal to I dou pi by dou x is y plus j dou pi by dou y is x plus k dou pi by dou z is minus 2z. Next, let us assume that the normal to the surface pi at the point 4, 1, 2 as pi 1 del pi 1 and the normal to the surface pi at the point 3, 3, minus 3 is del pi 2. Therefore, del pi 1 equal to del pi at the point 4, 1, 2. This equal to y is 1 into I, x is 4 j plus z is 2. 2 into minus 2 minus 4k. Del pi 2 equal to del pi at 3, 3 minus 3. This equal to y is 3. 3i plus 3j and minus 3 into minus 2 plus 6k. Now theta be the angle between pi 1 and pi 2, then cos theta equal to del pi 1 dot del pi 2 by mod del pi 1 into mod del pi 2. This equal to, so del pi 1 I plus 4j minus 4k dot del pi 2 3j 3i plus 3j plus 6k by mod del pi 1 square plus 4 square plus minus 4 square into mod del pi 2 3 square plus 3 square plus 6 square. This equal to I coefficient into I coefficient 1 into 3 plus j coefficient into j coefficient 4 into 3 minus 4 into 6 by root 16 plus 16 32 into 1 33. Next 9 plus 9 18 plus 36 54. This equal to 3 plus 12 15 minus 24 minus 9 by root 33 into root 54. This is minus 1 by root 22. This is cos theta equal to. So from this we get theta equal to cos inverse of minus 1 by root 22. Next example. Determine the constants small a and b so that the surfaces 5x square minus 2yz minus 9x equal to 0 and ax square y plus bz square equal to 4 cut orthogonally at the point 1 minus 1 2. Solution. So we have to take assumption, let phi 1 equal to first surface 5x square minus 2yz minus 9x equal to 0. Next, pi 2 equal to ax square y plus bz square minus 4. Find del pi 1 and del pi 2 at that point. Del pi 1 equal to I dou pi 1 by dou x plus j dou pi 1 by dou y plus k dou pi 1 by dou z. This equal to I into dou pi 1 by dou x, 10x minus 9 plus j into dou pi 1 by dou y. Y derivative 1 into minus 2 z plus k into dou pi 1 by dou z. Z derivative 1 into minus 2 pi. Next del pi 2. Del pi 2 equal to I dou pi 2 by dou x plus j dou pi 2 by dou y plus k dou pi 2 by dou z. This equal to I into dou pi 2 by dou x, 2a x y plus j into dou pi 2 by dou y. Y derivative 1 into a x square plus k into dou pi 2 by dou z. 2z into b. So 2b z. Next, we have to find del pi 1 and del pi 2 at the point 1 minus 1 2. One minus 1 2 equal to I into x is 1. So 10 minus 9 is 1. Plus j into z is 2. So minus 4. Plus k into y is minus 1. Minus into minus plus 2. So del pi 1 at this point equal to I minus 4j plus 2k. Next we have to find del pi 2 at this point. Del pi 2 at 1 minus 1 2 equal to, substitute x equal to 1, y equal to minus 1. So minus 2ai. Next x is 1 plus aj and z equal to 2 plus 4bk. Given that pi 1 and pi 2 cut orthogonally, then del pi 1 dot del pi 2 equal to 0. If theta be the angle, given that pi 1 and pi 2 cut orthogonally, this implies del pi 1 dot del pi 2 equal to 0. This implies del pi 1 is I minus 4j plus 2k dot del pi 2 minus 2ai plus aj plus 4bk equal to 0. So this implies I coefficient into I coefficient. 1 into minus 2a, j coefficient into j coefficient. So minus 4 into a plus k coefficient into k coefficient. 2 into 4b equal to 0. This implies minus 2a minus 4a plus 8b equal to 0. This implies minus 6a plus 8b equal to 0. This implies by dividing with minus 2 we get 3a minus 4b equal to 0. Denote this one as equation 1. So given that the surfaces pi 1 and pi 2 cut orthogonally at the point 1 minus 1 2. So therefore the point lies on pi 1 and pi 2. Therefore we know that the point 1 minus 1 2 lies on pi 2. We know that the point 1 minus 1 2 lies on pi 2. Pi 2 is this one. In place of xyz, we have to substitute 1 minus 1 2. Therefore x equal to 1, y equal to minus 1, z equal to 2 we have to substitute. This implies a x square y. So a 1 minus 1 minus a plus b z square. So z equal to plus 4b minus 4 equal to 0. This implies a minus 4b equal to minus 4. Solving equations 1 and 2, we get a equal to 2, b equal to 3 by 2, which are the required values of a and b.